Hi everyone, so in another Andy's whiteboard session, a fairly common question people ask is what sort of knock detection stuff do you use while you're tuning? So it's a fairly common question, so I think I better answer it. Now, a lot of times people don't really understand knock, how it happens and what the effects of that are, so let's talk about that for a second. So this is our combustion chamber here. Knock is basically when you start off the combustion. I'm going to put the spark plug in the top, in the middle, because, you know, that kind of guy. So it sets fire to this part of the mixture. The rest of this is still unburnt charge. And then as this part of the mixture burns, the temperature increases, the pressure increases, right, due to, you know, the ideal gas law. And so that actually compresses the rest of the charge. So if you compress it enough, then it will actually spontaneously ignite by itself, just, you know, as it does in a diesel engine. So when you get that, that means that we've actually got two separate sources of the flame front. And that means that it doesn't go out in the right order. It, you know, wipes the boundary layer off the top of the piston, which is what protects it from the high temperatures, and so you get localized melting of the piston, and, you know, pitting is what it looks like when you pull it apart. I'm not an expert in engine failure mode analysis, but or even in combustion analysis, but that's my understanding of how knock happens. Now, you notice that this is not a spontaneous event. It happens because we started the fire in the first place. So if you never actually fired the spark plug, you would actually not have any knock. You wouldn't have any combustion either, but you get the point. There's a separate issue, which is called pre-ignition, which is where it does actually spontaneously ignite by itself due to the compression, pressure and localized hotspots. So that's what happens in a diesel engine. In a petrol engine, what's supposed to be a spark ignition engine, it's not a good thing to do. In a diesel engine, the rate of combustion is determined by the fact that the fuel is actually continuously fed in during the combustion, whereas in one of these engines, the fuel and air all goes in together at the beginning. So if you set fire to it at the wrong time, it can all go up at once. Well, I mean, it doesn't go up at once, it still propagates, but it's bad. It leads to, you know, big holes in pistons and, you know, fire out the bottom, and, you know, everything's quite bad. So that's pre-ignition though. Not really talking about that so much, because once you've detected it, it's a bit too late. What we're going to talk about is knock, or detonation. And there's no such thing as pre-detonation. That's a non-word. So, for argument's sake, let's say we fire our ignition at, if this is our timeline of, you know, this 180 degrees before top dead center, top dead center, and that's bottom dead center afterwards. We fire our ignition here, then the flame starts to propagate, and then if we get knock occurring, then it's going to happen, you know, somewhere in here, in this region. It's going to be after top dead center, and normally it's sort of within, depends on literature that you read. In my findings, I've found it sort of between about 0 and 40 degrees after top dead center. Some of the other literature I've read has said between 10 and 70, but it's in that sort of region. Now, what does knock actually sound like? Basically, what the sound that you hear is actually just taking up mechanical slack in the engine. You know, moving the piston within the bore, and, you know, bang the rings up and down and that sort of thing. So it's all the loose bits in the engine. So in other words, it's the sound of the engine. It's the sound that an engine makes when you excite it mechanically. So the same way that a bell goes dong, if you hit it, an engine goes if you hit it, and if you hit it with lots of combustion inside continuously, it sounds like that, like a knock. So what that means is that a lot of other things are going to sound very similar, or any other way that you excite the engine mechanically is going to sound very similar. So for example, valve noise sounds very similar. VVL switching on and off sounds very similar, and that sort of thing. So The trick with knock detection is not so much to filter the right frequencies, that is, make sure you get the right sound, although that's important as well. The trick is to actually make sure it's happening within the window in which you expect knock, because we're not going to have valves opening and closing within this window, at least not on the cylinder. So we can exclude a whole bunch of other things that are not knock. So when people say that you can use a knock light or something like that, or some sort of a meter or an indicator, a bar graph or something like that, that just connects to a knock sensor on the engine, then that can't do this because it doesn't connect to the crank angle sensor and it doesn't know what angle the engine's at. So all it can do is look at the level, how loud it is, and depending on how bad the knock is and how quiet the rest of the engine is, that may be sufficient. But there's a reason why modern ECUs all use this crank angle windowing method. It's not just to work out which cylinder's knocking, it's also to reject things which are not knock. If you've got a knock sensor that's designed from the factory for that engine, then that can be quite effective. But again, things like a forged piston engine is going to sound a bit knockier, and it's going to give you knock readings even when it's knock. So some of our earlier ECUs used this method, which didn't have the crank angle windowing. They just had the monitoring the level, and then subtracted background noise and then looked for spikes above that. And it works all right for a lot of applications, but it's probably not the best sort of general solution. So that's one option, is the sort of the light option. Second option is also fairly low tech, and that is listening to it with a pair of headphones. Now there's a couple ways to do this. Some people have got their own mechanical contraptions, like a hose that goes onto the engine, and it goes into a pair of modified earmuffs. Whatever works for you, that's fair enough. There's also other things like the knock box, made by Smith's Racing Services and resold by a bunch of badge engineers, which is basically just a normal knock sensor, and it's got a little amplifier in a box with a volume control on it and a pair of headphones that goes into it, and that's basically just listening to it. So but because you're using your ears instead of relying on electronic processing that doesn't know this context, often that's a lot better than this, in my opinion, because especially tuners with experience will know, well, no, that's definitely not, because it happens just when I get on it there, and they can discriminate other noises. Your ears are actually very good at discriminating between noises. You can have, well, as an example, if you just take a piece of music and you listen to it, you'll be able to hear all the different instruments all separately in your mind. If you look at it on an oscilloscope screen, you have no way of separating them unless they're at completely different frequencies, and you can look at it and you know what you're looking for. So that's why I say ears are really good as well. The third option is to use a really high-end knock box. So I think Plex make one, and I think Formula make one as well. And they do actually connect to a crank angle sensor. So obviously there's a lot more setting up that you need to do with those, because it needs to be triggered just like an ECU does. But that gives you a much more reliable reading. And then the fourth way is the way I would do it, of course, which is through the ECU. Now, in our ECUs, you can set the frequency windows. So knock normally occurs between, say, 5 to 10 kilohertz, normally middle of about 7 kilohertz, that sort of thing. You can set that window in the ECU, and you can also set this window in the ECU as well. And the software actually gives you a live view of this and this, so you can see, there's that down there which is alternating noise, and there's this bit up here which is actually knock. So you can see where in the frequency band it's occurring, so you can set your frequency windows. And it also gives you a timeline like that of the engine over 720 degrees in 5-degree increments. And so you can see there's a little, hump there, for example. And, on one engine I did recently, there was a little hump there that was there all the time the engine was running. And I think it must have just been, injector noise or something like that, because it was always at the same angle. But it wasn't knock, happened at idle. So by doing that, you can make it knock and see where it peaks up, and then say, okay, that's the window we're going to look at. And then, of course, if you can listen to it as well, then that's doubly good, and that's why our ECUs have all got a headphone socket on them, so you can plug headphones into it and then listen. There's actually, I was talking to Andre at High Performance Academy about this. He said, can you listen to this gated signal through the headphones? So only listen to it during that window. And the answer is I've tried that, and it's really bad, because you have all this background noise. You have your knock signal, or maybe you don't, and background noise on top of it. And then if you don't have the background noise here, then your ear just hears this background noise being gated on and off. And again, your ear's very good at rejecting background noise, but when you start gating it synchronously with the engine, it becomes a new signal then, which overpowers the signal that you want to listen to. So we don't do that. Just have a headphone output, which you can program with your filter, and that works really well. Hope that's useful. So if you're going to be using tuning a whole bunch of different ECUs and cars and that sort of thing, I'd probably do it this way, I think, because this way I don't think is useful enough, and this way would probably require too much setup on each individual car, but I haven't really used these very much to be able to comment on those. So maybe ask some other people on the forum or the Facebook group, their experiences with these, and doing them on different cars, how long it takes to set up, if you have to wire in stuff and all that sort of thing. Thank you very much.